Hi, so I'm working for CodePlay, and my colleagues from CodePlay and Unitel would just be working on leveraging MLIR for a bit of SYCL compilation. So first, like, what is SYCL? It's an open standard to do heterogeneous programming, and API introduced by Kronos, provide a single source programming model for accelerator processors. So if you're familiar with CUDA or OpenCL, it's really very similar. It's using ISO standard C++ code and allowing you to access both high-level and low-level code. And there's multiple implementation: Compute CPP, C++, which is Intel 1, SYCL, which is University 1, etc. Right. So a simple example of what SYCL looks like. So here we have a vector addition written in pure SYCL. So the first pure SYCL object that we have is just a queue, which initialize the device and pick up here in that example, picks up whatever is available, and just gives us an object that is ready to use for us to submit jobs. Then we have buffers. So it's just a container that holds the data and actually tracks where the data lives. So if you have different devices, it will know where the latest copy is and schedule data transfers accordingly if necessary. But it never provides you directly access to the data. So when we submit jobs, we create normally first accessors, so that allows you runtimes to know what kind of data we need actually on the device, so you can schedule the data transfers. And then create an object that allows you now to access the data once you are on the device. So the current code that we have here is actually this last bit, which is a poly 4. So if you're familiar with CUDA, it's kind of equivalent to the triple chevron. And the lambda expression that's just below, the last line, is actually just the vector add in SYCL. So the aim of the project is just to get better optimization for SYCL compilers. So better optimizations on device code, but also trying to capture what has happened on the host and transfer that for better optimizations on a device. LLVM is not that enough. It's too low level for some advanced optimizations. We lose a lot of information when we move from Clang AST to LLVM. And there's currently no way to represent the host and the device in the same module. MLIR is a little bit better suited for this. We can get better high-level representations and gradually lower. And it will also give us the ability to nest host and device code in the same module. So that's the top of our project. So the current status is we're based on DPC++. We're still using the two-pass compilation flow that it uses, so host on one side and device on the others. We use polyguys to handle the C++ to MLIR translation. And we use a dialect that we developed, so SYCL-MLIR, to represent the high-level semantic that is defined by the spec. So this is the dialect that we use inside MLIR. So we get our own SYCL dialect. We also make use of the GPU's PAV, SCFs, and all those as well to raise to affine to get better optimization later on. And get this small polyguys dialect, which just make the glue code a bit of a glue to also play better with the LLVM dialect. And then once we have basically performed all optimizations and gradual lowering, we just flow back into LLVM IR and our traditional compilation flow. So an example of what we're trying to do, and actually what we do here is, so let's say we have like that accessor R that is accumulating the result of an expression. Here we're computing that address all the times, and we just want to host that outside of the loop. So if we do that in LLVM, we just basically end up with a bunch of function calls, which doesn't make any sense to us. We have a conversion from items to ID, and then we get a subscript operator call just to get an address from that. If we move to our MLIR representations, we get an explicit constructor that tells, oh, I'm constructing an ID from an item, so I'm doing that implicit conversion, and then I'm just computing a subscript operations, and then we directly embed this semantic in there. All right, so that was very quick. I have a poster at the next session, so if you want to talk to me and know a little bit more about this, just come to talk to me. Thank you.